So in this video lesson, we're going to be talking about percent composition and empirical formula. Okay, so a lot of times what we'll do is we'll need to determine how much of each element is present in a compound. And the way we can do that is by percent composition. The way we look at it is by mass. So it's the relative amounts of each element in a compound with regards to its mass. So what we're going to be doing is I'm going to show you how to do this. So I'm making, number one, a couple assumptions. Number one, you can convert grams into moles, moles into grams. You can determine the molar mass of a compound, and you understand what a percent is. All right. So first thing first, we're going to try it. We're going to do it. You're going to see how it is that we can determine the percent by mass of a compound. So I'm going to use the compound of barium chloride, BaCl2. And the question is, what is the percent composition of each element in a compound? And we always do this by mass, ladies and gentlemen, always by mass. So the first thing we have to do is determine the molar mass of the compound itself. So I'm helping you recognize that there's one barium for every 2 chlorine. And so I looked up on the periodic table, and again, we're doing this in the nearest whole number. So there are 137 grams for every 1 mole of barium, so I have 137 grams of barium. And for every chlorine, there's 35 grams. So because there's 2 of them, I multiply it by 2, and we get 70. So when I add that all together, I end up with 207 grams per mole of barium chloride. So this, folks, this barium chloride, by the way, this is the total, all right, or what I refer to as the whole. And whenever we do a percent is always the part over the whole times 100. So that'll give us our percentage, okay? So let's take a look how it is that we're going to use this. These are the values we're going to use. So out of the part, there are 137 grams of the barium, all right, and 70 grams of the chlorine, and the whole would be 207 grams of it, all right? So let's take a look. A percentage is part over a whole, so part of the mass, one element over the whole molar mass of the compound. All right, so if we look right here, the way I would set it up is I would take my 137 grams of barium, divide it by my 207 grams of the barium chloride, multiply it by 100, and that's my 66%, and this would be of the barium. All right, now we continue on, do it for chlorine. 70 grams of chlorine out of every 207 grams of barium chloride multiplied by 100, we end up with 34% of the chlorine, okay, 37% of chlorine. Now, if everything works out according to plan, when I add these up, this should add up to be 100%, and for this one, it does. And you might end up with something like 99.9% or 101% or 100.1%. All of those are good. It's when you end up with things like 95 or an 85 or 115%. You know that you either have the part wrong or the whole of the molar mass incorrect. All right? Now, you're going to say, well, what would I use this for? Well, usually we can figure this out and we can determine the percent of each element in a compound, and it tells us how pure the compound is, and that's one of the great ways. Another thing we could do is we can actually work this in the opposite direction. And we can actually determine, given the percentages, we can determine the empirical formula. The empirical formula is what is referred to as the lowest whole mole ratio of a compound. And it's usually reserved for ionic compounds, but you can also do this for molecular compounds as well, okay? So the question is, if you are given the percent by mass of each element in a compound, could you determine the formula of the compound? And the answer is yes. And the reason I have a picture of a lab in here is because, folks, this is actually what folks do in crime investigations. If they find an unusual substance, they can actually run it through an NMR machine and be able to determine the percent by mass of each one of the elements in the compound. And from there, they can actually determine what the compound is, okay, meaning the formula. So oftentimes I used to watch a show called CSI, and they would literally take it and find this one little paint sample from a car, and they'd be able to tell what kind of car it came from because all paint is proprietary and must be registered. And so they could actually determine each and every single one of the elements in the paint compound, and then they'd be able to tell what car company it came from and what type of car it was. So again, Here's the most important definition I need you to know for empirical formulas, and it is the lowest whole mole, and this is the key, lowest whole mole, all right? And I need you to add that, mole, number ratio of the elements in a compound, all right? And to determine, you need a couple different things. In order to determine the empirical formula, you need to know the mole amount of each of the elements, okay? And this can be determined either by given the percent or the mass of each one of the elements in the compound. So, excuse me, if you're given the percent composition of each element in the compound, we are going to assume a 100-gram sample. And you're like, well, why would I assume a 100-gram sample? Well, if we're assuming a 100-gram sample, that will make it so our percentage, which is 100%, can be considered to be now 100 grams. So if we have the percentage of each one of the elements, we can then therefore say, oh, well, it's got this many grams of this element in it out of 100, okay? If you're given the mass, you just simply convert the masses into mole, and then you can create what is called a mole ratio, which I'm going to show you how we do. All right, so the question is, here's the question we're going to work on. What is the empirical formula of a compound that is 25.9% nitrogen and 74.1% oxygen? So we right off the bat know that this compound is going to contain nitrogen and oxygen, okay? We don't know what the subscripts are be. So the idea is that we want to know what the subscripts are going to be, whether it be a 1, a 2, a 3, a 4, a 5, 6, 7, 8, 9, 10, I can go on forever, okay? So the first thing we're going to do is we are going to assume a 100-gram sample. When we do that, instead of thinking of the percentages of each one of the elements, they are now grams of each one of the elements, okay? And so instead of it being 25.9% nitrogen, it's now 25.9 grams of nitrogen. Instead of it being 74.1% oxygen, is now 74.1 grams of oxygen. Because if I add this up, this is 100 grams of the compound, which is also 100% of the compound. So, going back to the definition of an empirical formula, it is the lowest whole mole number ratio. So we've got to convert these grams of nitrogen and grams of oxygen into moles of oxygen. So we think in the unit of mole, all right? And remember, these elements combine in whole number ratios. So the first thing we're going to do, I'm going to take my nitrogen using the molar mass, all right, which again, we get from the periodic table of elements, okay? We end up with a value of 1.85 moles of nitrogen. And then for the oxygen, we end up with a value of 4.63 moles of oxygen. So if we put this into a formula, we would just simply write it as N1.85 O 4.63. Now, last time I checked, these are not whole numbers, okay? So we need to compare the two values together to make it so that we can create them into whole number values. And the easiest way to do that is to divide by the lowest number. And let me show you what I mean. Meaning, we're saying right now that this is 1.85 to 4.63, okay? And what we're going to do is we're going to divide by the lowest number to guarantee that we will end up with at least one of these values as a whole number. So let me show you what I'm talking about. All right, we're going to compare the values. So when I do compare and I take the 1.85 divided by the 1.85 and the 4.63 divided by the 1.85, N automatically becomes a subscript of 1. But you'll notice that the oxygen becomes a subscript of 2.5. That's still not a whole number, but could we make this into a whole number? A ratio of 1 to 2.5 is, well, how can we get rid of the half? If you said multiply both of these by a value of 2, then you are correct. We now end up with a whole number, and we end up with the formula as N2O5. That's how we do empirical formulas. You're going to have some practice to do later on today.